Cool. So we'll be discussing about what the OS does and how it works. So, like, first question, what is OS? That is operating system. So, an operating system is just a process. Uh, which brings us to another question, what is a process? So, a process is basically a program that is running. A program is something that is stored in the disk. Okay, first of all, the computer is divided into the CPU, the RAM, which is also called the memory, and a disk, and some input output devices and all. So, uh, like data that is like sort of permanently stored is there in the disk. Data that is currently being operated on and is required is in the RAM, and the CPU actually does all the processing and all. So I assume you guys, yeah, everyone is like familiar with how programs are executed. Like, just a short summary, there is something called an accumulator, along with that other resistors. So these things store values, and so basically stuff, and there is a register called the program counter and all. So the program is data that is there in the memory, and with the help of all these resistors, uh, the CPU basically knows what instruction to execute right now, how to decode it, and what to do when you're actually executing the instructions, like everything from clock cycles and everything. So all that is done in the CPU, and the program is stored in the disk, which is brought into the RAM for execution. So all this thing of executing a program is called a process. So yeah, coming back to the operating system, an operating system is just a process, and it is the first process that runs on your computer. So uh, but basically the operating system itself is like useless. Like, you can't really do anything other than run other processes on your computer using an operating system. So, like, the main question that we're trying to figure out here to understand how an operating system works is how an operating system runs other processes. So uh, basically, I'll tell you first what a process does when it's running. So when a process A is running, let's actually consider OS only. So when the OS is running, um, it needs to basically make use of the hardware. So so the OS has to have control of reading writing to the disk, then reading writing to the RAM, and it also has to have control of input output devices. So yeah, that is like sort of the bare minimum, and it also has to have control of starting and stopping new processes. So that is what the OS should have. So when the OS is in action, it has control of all of this. Um, and keep in mind that even though on our modern computers it feels like so many programs are running together, if there is one CPU, only one process can run on it at a time. Because think about it, only one instruction can be executed at a time. So, how will two instructions of two different processes run together? They can't unless we smartly sort of schedule one process after the other. But we'll come to that later. Basically, right now only one process is running on the CPU, and that is the OS. And this OS has control of all the hardware. That includes all our personal files and all the output to the device, the output to our devices, and yeah, all that the OS is control of. So now we want to run, for example, Discord, and so Discord, if Discord wants to run, it has to gain control of the CPU, because remember, only one process can run at a time. So let's discuss a naive approach to running Discord. First, the OS is running, and now we say OS don't run, and now we say Discord run. So now Discord will have control of the disk. It will have control of the RAM. Uh, so does that mean now Discord can read whatever data is there on the disk? Like, suppose you have some personal files or something which only like some specific users can access, or like you have whatever encrypted files and all which require passwords to open. All that is there on the disk. So if you give entire control of your computer to Discord, then it can do all that essentially. If you give it equivalent permissions like the OS. And you don't want that, even though we like Discord, it's nice and all, but we don't want Discord to do that or any other process other than the OS, of course. So what we do is, or rather, what computer scientists have done is created two modes of running the computer. One is the mode that the OS runs in, that is the kernel mode, and one is the user mode. So all other processes that you don't want direct access to your computer's hardware, uh, run as user programs, and they run in this user mode, and the OS runs in the kernel mode. So, what is the difference between these two modes? So, as I explained earlier, OS has control of everything. It can literally crash your computer, whatever it wants to do, the OS can do. But the user mode cannot do that. The user mode, user programs, they cannot access the disk directly. They cannot access input output devices directly. Basically, all these things they cannot do directly. But say we were talking about Discord. So Discord does access your computer's files, right? Like if you want to say upload a particular file, then you need to access it. And similarly, like any other program, like a code editor or whatever, will obviously access files on your disk. So how do you do that if you haven't given access to user programs in user mode? So basically, user programs have to ask the OS that give me permission to read this, give me permission to read that. So say you're using VS Code, and there is a file called a.cpp on your computer, and you want to read that. So VS Code will ask the OS that, hey, I want to read this file, give me access. Then, okay, another thing, if you remember, only one process was running at a time. So what is the point of asking the OS to give you access if the OS isn't running? It obviously can't give you access if it isn't running. So what is done is that temporarily, before reading this file, control of the CPU is shifted to the OS, and we'll discuss how that's done in detail in a while. But basically, yeah, first VS Code was running. It asked for access to read from a file. Then the OS was running. It checks whether VS Code has permissions to read that file. So something like a.cpp, which VS Code will have permission. So the OS will be like, okay, yeah, you have permission. So the OS will read the file and send whatever output was there to VS Code, and then VS Code will again continue running, and now it will have whatever output it required, that it wanted to read from the disk. In case that VS Code did not have access to the file that it wanted to read, the OS will just return like some error or something as the output, and VS Code will start running again. But now it has to decide what to do now that the OS has whatever, like, rejected the access permission earlier. So that is how basically processes access like important things like the disk and IO. They ask the OS, and the OS then grants permission, and it does not only grant permission, it gives the output. So how do these things ask the OS? They can't just be like, hey, give me this. But no, actually they do it in that manner. So the OS has something called Syscalls. So these syscalls are basically access requests for the OS to read the disk or like input-output devices, whatever. So some examples of syscalls are open, which basically opens a file, then read, which basically is for reading the contents of a file, write, then exit a process. All these are syscalls. So the programs will tell the OS to do this, and the OS will do them. Uh, so yeah, basically processes use syscalls. But one more question is that where are these syscalls? Like, uh, if they are stored on the disk, then a process can't access it because a process can't directly access a disk. And to access the disk, you have to make a syscall. So like, what? What? So basically, these syscalls are written separately using hardware, separate than in an area separate than the disk, where the processes can access them, and this is done during boot time. So yeah, basically the processes have access to syscalls, and when a syscall is called, basically you want to shift control to the OS, right? So the current running process, say Discord, it needs to stop, it needs to save whatever values it was working on, like the register values and all that. It will store it in something called the kernel stack, and it will shift control. So it will trigger something called a trap. So this trap will basically shift control to the OS, and after control is to the OS, it will do whatever it wants. It will, suppose the call was of read, it will read whatever contents Discord wanted it to. It will store the output in some register, and then it will do something called return from trap. Uh, so in return from trap basically does the opposite of trap. Basically, all the things from the kernel stack are again stored in the registers, and control is given to Discord. This is how a general syscall works. Um, so yeah, this is how OS takes care of running processes. This is also a way to ensure like security and all, to make sure like a process doesn't access stuff that it's not supposed to. But there is another problem that we have in this kind of implementation, is that what if a process doesn't make a syscall? Like, suppose you're on Windows and you open Discord, and suppose Discord just doesn't make a syscall, it just keeps running, and now you want to open, say, Chrome, but now you can't open Chrome because the control is not in Windows hands, it's in Discord's hands. So like, how do you solve this problem? So this problem is solved by something called a timer interrupt. And what it does, so what are first of all, what are interrupts? I think you'll already be knowing this, but interrupt is basically something coded in the hardware that you can trigger at any time, and that it does a bunch of instructions that it's supposed to when it's triggered. So what the timer interrupt does is, even if a syscall is not made after say 10 milliseconds, okay, I don't know how long this time is in like computer terms, but for example, so in after every 10 milliseconds it will transfer control automatically to the OS from whatever running process it has, and the process of like the way the control is transferred is similar to how a trap instruction is called. Like, all the registers will be saved of the running process, and then the OS will start running. Now the OS knows that it has been called from a timer interrupt, and now it will decide what to do, like whether to keep Discord running or whether it wants to do something else. And that we'll come back to this something else. But yeah, it can do basically whatever it wants, and this will ensure that one process doesn't take over the entire computer, basically. Even though if it is not damaging the computer, this can still hang the computer. And yeah, if you run something like a while one, which obviously everyone has once in their life, so yeah, this will basically keep running if this timer interrupt wasn't there. So this kind of approach was actually used in some computers. I think Mac did it in their OS in some 1880s or something. This is called the cooperative approach, where computers just don't expect such bad processes to run. And then there is something called non-cooperative approach, where the timer interrupt basically gives control back to us. But yeah, so this exists, and that takes care of the while one issue. And yeah, we discussed how a process runs and how a process uh, gives control back to OS and how it accesses the disk. But you might be wondering, this was only about one process. How do multiple processes run at the same time? Because, like, for example, now I am running OneNote and I'm also screen recording. So, how does that run at the same And I'm also running Windows. So, um, yeah, so how does that work? So basically, it works in a similar way how Windows and a process kind of runs at the same time. Uh, in low level terms, only one process is running on the CPU. But if you look at the bigger picture, that process A is running. It is giving control to the OS, and then the OS can actually decide what process to run next. Suppose it wants to run B process next. So instead of transferring control back to A, it will just transfer control to B. And this process of the term process is actually a bit misleading in this context. So yeah, the way, we'll just call it the way. So the way of transferring control from one process to the other is called a context switch. And how does this context switch occur? So we discussed what happens when A transfers control to the OS through a trap, and here the resistors of like the resistor values of A are stored in the kernel stack, and then the OS does whatever it wants. And then if A was supposed to be run again, return from trap. If A was supposed to be run again, then the values from the kernel stack would be restored. But what if B wanted to be run? Now the values in the kernel stack are actually corresponding to A, right? So these values will be stored in the RAM somewhere. There is like a specific structure in all operating systems for like storing the contents of a process. So it will be stored in the RAM according to that structure. Then if you want to run process B, whatever values it has, register values, they will load into the kernel stack, and then that return from trap is again called. So now it was as if process B was running first. So it will load all the values from the kernel stack and run process B. And this is how like the OS runs, sort of gives the illusion of running multiple processes at a time. And this entire process of sharing the CPU and giving the illusion of multiple CPUs is actually called CPU virtualization. It means like you have sort of multiple virtual CPUs, and obviously if you want to give a good illusion of running multiple processes at the same time, then you have to optimize this context switching and all. Basically what that means is you need to know which process to run when, and you also have to design all the operating system like methods and protocols such that the OS itself does not consume much CPU time. Yeah, because that would just be a waste. And Yeah, and this which process when actually includes um, what order the processes should run in, and it should also ensure like there is no free time that the CPU gets. Like it should keep running. Basically, like say if you are running a code, some Python code, and you are waiting for input, so the CPU shouldn't sit idle at this time. It should constantly keep checking like other processes and running them, and like or it should also take the input like sufficiently fast and all that. So all that should be managed in like that context switching optimization and all. And yeah, basically this is covered under something called scheduling. So uh, wait, who's here? Hello Abhishek, I am teaching a bit of OS, you want to listen?
अच्छा मेरे को लगा तेरा कुछ और चल रहा था, तू बस ऐसे ही स्क्रीन शेयर कर
No,
आरजो को.
I am teaching. I'm actually recording a
नाइस.
YouTube video right now, so you're on YouTube.
ओ हेलो यूट्यूब.
Okay, so I'll continue. I'll just give a recap to Abhishek of what we covered till now.
Oh, by the way, I started doing Code Forces contest, and your rating is going real down.
लाइट ब्रो, उड़ जाएगा बाद में.
Hello, are you live on YouTube?
Not live, but yeah, I'm going to upload this.
Don't cut this part, okay? I
Yeah,
have
yeah. You think I'll take the effort of editing the video? I'll just upload
yes.
it as it is. So yeah, basically right now I covered like what a process is, and the OS is basically a process, and how the OS runs other processes, and how it uses syscalls for that, and how multiple processes are run at a time, and that's why it gives the illusion of like so many processes running and all. That I covered till now. Uh,
या
अभी तक क्या और क्या बाकी है? Actually yeah, I wanted to cover only this thing अभी इस वीडियो में. This is like एकदम ऐसा basic introduction. um, what else is
तेरे को
left?
बहुत अच्छा लगा क्या वो बस.
बहुत. So oh yeah, I am reading about OS from Remzi. His first name is very hard to pronounce, but yeah, Google operating systems 3 easy steps. No, 3 easy pieces. It's called O step. That is the
आर
best
यू
book.
टेलिंग मी
No, I am telling
व्यूअर्स.
YouTube. तुझे तो बताइए.
ओके.
Yeah, basically Remzi rocks. Um,
Abhishek, तेरे को अच्छे से नहीं पढ़ना, right? OS, like you don't want to
that is
like.
it for this video. Bye bye.
I think I will need a little bit of knowledge about